Hey everyone, to help out on 3-2, I'm going to go ahead and record me going through the homework through ALEKS to make sure that we know how to graph, doing it specifically on ALEKS so that you know what it looks like. Hopefully this helps out. So it's going to be similar to the examples we did during class, but they are going to be a little different just solely because it's ALEKS and they come up with random numbers and they change the problems all the time. So it's not going to be the exact problem we did in class, but they will be very similar with just different numbers. Go ahead and share my screen with ALEKS. All right, so one of the things I would make sure that you go ahead and have open is go ahead and have Desmos open because we are going to be using that to help us graph. So we're going to go ahead and take a look at the 6 questions that we do have on your homework. So for question 1, it's just going over analyzing the system of equations that they have, and you're just trying to choose the better choice. So here we have Shin can choose plan A or B in his long distance charges. For each plan, the cost in dollars depends on minutes used per month as shown below. So if we look here, it says Shin makes 100 minutes of long distance calls for the month. Which plan would cost less? So I'm going to go over here and 100, and whichever one I hit first is what's going to be the cheaper one. And so it's blue, so that would be plan A. And in blue, it's at $12. But actually, that is not the question asked. The question is the difference in price. How much less does it cost than the other plan? So this is at 12. This one is, this one's at 12 and this one's at 18. So it'd be $6 cheaper. And then for what number of long distance minutes do the 2 plans cost the same? So we're looking for our intersection, and it's at 250. And if time spent on the long distance calls is more than this amount, which plan costs less? And we'll see that it's plan B because it's below A after that point. And I can hit check. And that's how you go ahead and do that problem. For this next one, I'm going to go ahead and use Desmos. It says to graph the solution to the following system of inequalities. So I'm going to go ahead and graph both of these. So we have y is less than 2. Y is less than or equal to negative 2x. I believe it said, and it did say plus 7. So looking here, I'm going to plot these 2 points so I can graph my line. And do notice it is a solid line. So I'm going to go ahead and graph the point 0, 7, as well as the point 3.5, 0. And I can do 3.5 because that is an exact value versus it's not approximate. So I'm going to draw a line between these two, using these 2 points. And I'm going to go ahead and leave it solid. Next, we're going to do 3x minus 5. So y is less than 3x minus 5. So I would use the 0.5, negative 5, and the 2.4, comma 2.2. You could use this 1.667, but at that point, it's better to have this as a fraction because this would actually get you the wrong line if you used this decimal. This decimal is the same thing as 5/6. I'm sorry, not 5/6, 5/3. So if you're going to use the intersections, you would need to use 5/3, comma 0, and then 0, comma negative 5. So let's go ahead and do that. So we have 5/3, comma 0, plot point, and then 0, negative 5, and plot point. So I'm going to go ahead and graph. Let's start with this one, and then it's this one. And that is a dashed line, so we're going to go ahead and change that to a dashed line. So I'm going to select that for when I want dash. And then we're going to take a look and see where the double shaded region is. So this area here, which is darker, is my double shaded region. So I'm only going to shade my solution on ALEKS. So only the section that is a solution. And so that's how you go ahead and plot there. So let's go ahead and take a look at the next one. Very similar, the only difference now is that we have them in our equations in standard form or inequalities, and they want a point that's in the solution set. So we're going to head and do the same thing. We're going to do negative 4x plus 7y. So negative 4x plus 7y is less than negative 21. All right, so here I have two coordinate points. I'm going to do 0, negative 3, and 5.250. And notice it is a dashed line. So actually, I can go ahead and make this project. So it's a dashed line. So we're going to head and do that. We had 0, negative 3. And I do believe it was 5.25, comma 0. 5.25, comma 0. I'm going to plot that. I'm going to head and draw my line. I'm going to head and change it to a dashed line. All right, so next I'm going to head and graph 5x plus 3y is greater than or equal to negative 3. 5x plus 3y is greater than or equal to negative 3. And I'm just going to double check. 5x plus 3y is greater than or equal to negative 3. So I'm going to plot my points. So I'm going to do 0, negative 1, and negative 0.60. 0, negative 1, plot point. Negative 0.6, comma 0, plot point. And then draw my line. And so that is a solid line. So now we're going to look for the double shaded region, which is going to be this region here. So we're going to shade that. And so this time they want you to go ahead. Oh, interesting. There we go. So we're going to just label a point. Anything in this shaded region would work. So I could do like 10, 0. I could do 20, negative 10 would work. So I'm just going to go with 20. They might want it actually shown in there. So I'm going to do 10, 0. And so that works. If you choose, sometimes they will want you to make sure that's actually you can see it. So that's why I had went with 10, 0 instead of 20, negative 10, just as a heads up. I could have also gone with 10, negative 10. Anything in this shaded region is fine. Also, anything actually on this solid line at the bottom of the shaded region would also be okay. All right, so next we're going to graph this time 3 and going to shade in the triple shaded region this time. So let's start with, so I can actually draw something. So I know when y is at positive 7, and that's a solid line. And I can also do negative 3 for x. So I do know that part here, but I'm going to go ahead and draw them anyways in Desmos to be safe. So the first one we have is negative 2x plus 3y. Is less than 9. And then we had x is greater than or equal to negative 3. And then we have y is less than or equal to 7. So on this red line, I'm going to head and plot 0, 3, and negative 4.50. So 0, 3, and negative 4.50. I'm going to draw my line. And that line is a dash line. And then the center point that makes a triangle is our shaded region. Oh, something's wrong. What did I do wrong here? Oh, I see what I did wrong. So I plotted the wrong point. So it is going to be negative 4.50. And then we said negative 3, 0. Oh, sorry. This one's negative 3 and this one's 0. Oh, positive 3. What was I doing? There we go. And this line is dashed, and then this line. Let's see if that is it. And there you go. So sometimes you do need to make sure that you sketch the right graph. So obviously when I drew my line earlier, it wasn't right, and I needed to go ahead and fix it. Not a really big deal. It's something easily done. You still get full credit if you have to readjust it a little bit. And that's why I always suggest doing the plotting the points. When you're drawing the line and letting them plot it for you, that's actually a little new. That is an update on ALEKS that wasn't there before. All right, so next we have our word problem. Kareem's final exam has true, false questions and multiple choice questions. The table below shows how many points each of these are worth. Let X be the number of true, false. Let Y be the number of multiple choice that he gets correct. And he needs more than 82 points on the exam to get an A in the class. So using the values and the variables given, write an inequality. So true, false is worth 2 points, and that is X. If we add that to the 5 points per multiple choice, we will get his score, and we want that to be greater than or equal to 82. I had a feeling that was going to be the case. I have a feeling they want 82 over here. And we're going to, the highest, but there's also an upper region that he can only get 100 is my guess. So let's see. Oh, it can't be equal to. Interesting. He wants to get, he needs to get more than. So here's when you have to make sure you read what they say. So since they said more than, not at least, it wouldn't have the equal to symbol. So let's go ahead and try another. So Bob plans to run and swim laps. It shows you how long he takes for each run and each lap for swimming. So R is going to be the number of laps he runs. S is the number of laps he swims. He wants to run for exercise at least 30 minutes. So here they use the word at least, so that does include the equal to. So if we're going to do 5R plus 3S is going to be greater than or equal to 30. So again, this is where it makes sure we do know what they mean, and you do need to be very careful reading, as you saw in the last example, that vocabulary does matter. All right, next we have Ivana will donate up to $460 to charity. The money will be divided between 2 charities, the City's Youth Fund and the Educational Growth Foundation. Ivana would like the amount to donated to the EGF to be at least 3 times the amount donated to the CYF. Let X denote the amount in money and dollars donated to the CYF, and Y be the donated for the EGF. Shade the region corresponding to all values of X and Y. So this one's a 2-parter in that you have to write your system and then go ahead and graph it. So looking here, I'm gonna see if I can go ahead and copy this. I'm going to add a note. So I'm going to add this. I just copied it into there so I can at least have it on the same page so I don't have to go back and forth. And something I would also go ahead and do is, if you can look at this region that they have negative 120 to 520 on both. So I'm actually going to change my viewing from negative 120 to 520 for both my X and Y. So negative 120 to 520. So that way at least I know what it's generally. So between the two, she's going to add them up, and she wants to donate up to. So I can do less than or equal to 460. And then she wants the amount donated to the EGF to be at least 3 times the city fund. So the city one is going to be X. So we want excuse me, Y to be greater than or equal to 3X. And I'm just going to read that one more time to make sure that is what they meant. Ivana would like the amount donated to the EGF to be at least 3 times the amount. So at least means I can have more than that. And X is the city youth and Y is the EGF. So here is what my graph would look like. So we're going to have some coordinate points for me to plot. So I have 0, 0, and 115, 345. So I'm actually going to go with 0, 0, and then 115, 345. So 0, 0, 345, and it's solid, so I don't need to worry about that. And in purple, 0, 460, and 460, 0. So that's a really easy one. 460, 0 plot point, and 0, 460 plot point. And then I'm going to draw my line. And the other thing, we actually need to have a third limitation, and in that she has to donate money, not get money. So we're going to have to say that X plus Y is between 0 and 460. I won't let you do that. So we're going to go ahead and also add that X plus Y is greater than or equal to 0. No. We're just going to shade above. So we're going to do with X greater than or equal to 0. No, I want Y. And also, but X also has to be greater than or equal to 0. So there are a couple other limitations here, because you can't donate less than $0. So that's something to keep in mind here, that we do have a limitation because we are talking about money. So we're going to head and also graph that line, graph this line. Because of limitations of it being money, we have to make sure that we're in the positive. So this here is what I could do. I wonder if it wants me to delete this. Oh, I had the wrong equation. Which one was wrong? So I'm gonna have to go look at the explanation. What was the equation that I wrote wrong? x plus y is greater than 3x. What did I write? Y is greater than. Did I just not draw the right line? Oh, I just didn't shade the right region. Oops. So the correct region was this region, not this region here. And so that is one of the issues, though. Once you go over 2 or 3 lines, it's hard to see what they actually wanted. So I'm going to go ahead and do that one again. But I should have shaded this region here, not this region here. So I'm going to go ahead and do another one. So my bad. You guys get to see an extra example now. That's all it is. So I'm going to copy that so I can see it over here in Desmos. This time we have Maria, and I think actually, well, I'll take a look at that. So Maria does a weekly exercise program consisting cardiovascular work and weight training. Each week she exercises for at least 7 hours. She spends at most 9 hours on weight training and spends at most 3 hours doing cardiovascular work. Let X donate the time and hours that Maria spends doing cardiovascular, and Y be the number of hours that she spends on weight. So one of the things we're going to go ahead and do is that X has to be greater than or equal to 0, and Y has to be greater than or equal to 0 because she is working out. And I wonder, there we go. So we can actually go ahead and lessen the how dark it is. And so that might actually help us out a little bit to see. So I know it's going to be in this region here. So she spends at least 7 hours. So X plus Y has to be greater than or equal to 7. And I'm definitely going to change that color. Let's go with red, and we're going to make that a 2 instead. Another option we do have actually when we do this is if I make them all red, then it's going to be the one that has the darkest shaded. There we go. That might actually help us out here. All right, and then we have, she spends at most 9 hours on weight. So X is equal to or less than 9. And then we have, she spends at most 3 hours. So on cardiovascular. So I'm going to make sure. Oh. So 9 goes with weights, and weights is denoted by Y. So this should have been a Y. A little bit of that. And then we have X is at most 3 hours. So again, I'm going to change this to, we're going to also make it lighter. Make that lighter. So if we zoom in, we do have a very narrow area, which is going to be, she spends at most 9 hours on weight training. So this actually needs, that is right. And if you're trying, so one thing I might do to figure out where is it, as you undo, you can see, kind of start seeing where they overlap. And it's going to be this little pentagon here. So we can go ahead and graph this. 9. And we have 3. And then X plus Y is 7. So for my diagonal, 0, 7, and 7, 0. So actually 0770. Should be that region there. And I'm just going to double say, make sure it doesn't say at least on these. So at most 3 and at most 9. And there we go. So that one does take a little time to set up and do. But it is very important that you are careful and that you are paying attention. Do take advantage of the things that Desmos lets you do. You can change what it lets you see and how you see it. You can change the colors. And so that's probably gonna be the biggest thing that you do to take advantage of this, is using that to your advantage to make sure you can see. And again, always, if you're not sure what shaded region you're supposed to shade, slowly and undo them and then redo them and trying to see like, okay, well, what am I looking for? And that might help you out a bit. But those are the examples that we would have for 3-2 in class. So hopefully that helps you out, and I will see you next time. Bye.